In the short video, we're going to discuss the standard equations in the graphs or the curves, and also we're going to illustrate here the equations using the online graphic tools. So first of all, we're going to discuss the circles, then we'll discuss the equations of the ellipses and the parabolas, and at the same time we're going to discuss the functions of these curves. So the equation of the circle in the general form has this form, where a and b are the coordinates of the center of the circle, and the r is the radius of the circle. For example, the equation of the circle was the center at the 3 and 4 and the radius 5 can be written in this form. So I'm just going to substitute the a was the 3, b was the 4, and r was the 5. So if I substitute those numbers to this equation, I would like to get this equation. If I open up all the brackets, I will get this equation. So if I just substitute, so if I just eliminate the constants, so you see, so the 9 plus 16 is equal to the 25, so it can be eliminated with this 25, I will get this equation. So all of the three equations are the equations of the same circle. So the important reason why we need the equations is that I would like to find the coordinates of the points along the curve. So basically, if you're given some x points, how to find the points, exactly the coordinates of the points along the curves. So for example, we're given a circle with the radius 3 and a center 0 and 0. I would like to find the coordinates of the points where x is equal to the 1. So x is equal to the 1. So give me the coordinates of these 2 points along the curve, right? So I know that the x coordinates of both of these points are 1. So just let me know what is the y coordinates. So the idea is to find this. So first of all, we need to bring the equation of the circle, which is x squared plus y squared is equal to 9. And since I know the x coordinates of the points, I can just substitute the x coordinate to find the y square. So please note that every equation, is every point on the curve should satisfy this equation, right? So let us substitute the x to be equal to the 1 to this equation to obtain this equation. So basically 1 plus y squared is equal to the 9, and I can find the y squared is equal to the 8, and the two values of the y will satisfy this equation, right? So it is square root of 8 was the plus and square root of 9 was the minus. So basically the coordinates of the 2 points along the curve was the x coordinate to be equal to the 1 or 1 and square root of 8 and 1 and minus square root of 8. So now let's discuss how to represent the equation, how to represent the curves using the functions. So the basic definition of the function is that this is the spatial relationship between the two sets where each input has a single output. So it is not possible that a function can give you the two different outputs for the same inputs. So it is often we write the y is equal to the f of x, the function, where x is going to be called the input and y is going to be called the output value. So in order to check graphically whether the curve is the function, can be represented as some function or not, we need to use the vertical line test. So this is the test, the visual way to determine whether the curve is the function or not. So basically, so we know that a function should have only one output to each of the unique input, and if a vertical line intersects the curve at the 2 points, it means that the function has the 2 outputs for the same input, right? So graphically it looks like this. So this is the equation, so this is the line, and I would like to know whether the equation of the line can be represented as a function. So yeah, so no matter where I put the vertical line, it's going to intersect me with this line only once, right? At most once. So at the same time, the equation of the circle is not a function, because for example, if I intersect the curve, the circle at this point with this vertical line, it's going to intersect the circle at the 2 points, right? So the vertical line test tells me that it should intersect the curve at most once, right? So for example, here it doesn't intersect, but here it intersects the 2 times. So in order to represent the equation of the circle as a function, we need to figure out, or we are going to consider the equation as in different parts. For example, if I figure out the equation of the circle, which would automatically restrict the y to be positive always, then this would be a good function, right? So because no matter where you put the vertical line, it's going to always intersect with this curve only once, right? Or at most once. So from the general equation of the circle with the center at the origin, I can find that the y is equal to the plus minus r squared minus x squared. So if I just take the positive r squared minus x squared, it's going to be the equation of the upper circle. If I take the square root of the r squared minus x squared, it's going to be a function or the equation of the lower part of the circle. So let us illustrate so what we've learned so far as the online illustrating tool. It is called the GeoGebra. So you can just start graphing here and you can just draw the circles. For example, let's start with drawing a circle with the center, let's say at the 2 and 3. So the coordinates of the centers are 2 and 3, and it was a radius 1. So you see, so it's going to be a circle with a center x coordinate 2, y coordinate is 3, and the radius is equal to the 1. So now, if I would like to, so let's delete this in order to draw another circle. So now we say that the upper part of the circle can be written as a square root of the radius in the square minus x squared, right? The center is still at the 0 and 0. So if I would like to draw the curve x squared plus y squared is equal to the 3, it's going to be a circle with a radius, so let me put this 9 here. So with a radius 3 and a center 0 and 0. So now if I would like to just draw only the upper part, basically restrict all the y's to be positive, so I can draw this as y is equal to the square root of 9 minus x squared. So in this case, I automatically restricting the y to be always positive. And so this is the equation of the upper half of the circle, and at the same time, this is the function. So if I put here the minus, it's going to show me the lower part of the circle, and at the same time, this is the function because every vertical line is going to intersect with this curve at most once. So let's do some exercises. So let's say I would like to find the equation of the circle, this one and this one. So from here I see that the center of the circle is located at the point 1 and 0. So basically x coordinate of the center is 1, y coordinate is equal to the 0, and the radius is equal to the 1. So I can build up equation like this. So x minus 1 is in the square plus y squared is equal to the 1. From here I just need to find the y positive part of the y, right? So x squared minus tx plus y squared is equal to the 1 because the 1 and this one will be cancelled. And the y is equal to the tx minus x squared is going to be equation of the circle. So let's just show it. So y is equal to square root of tx minus x squared is going to be equation of the circle, right? Upper or half a circle, semicircle. So the second semicircle, it's going to be centered at the 4 and 0, and the radius is 2 now, right? So I'm just going to put this to this equation. It's going to be x minus 4 in the square plus y squared is equal to the 4. By just simplifying the expressions, we can find that y is equal to the minus 12 plus 8x minus x squared. It's going to be an equation of this semicircle. So let's show this. Minus 12 plus 8x minus x squared. So you see, so this is the equation of this semicircle with the center at the 4 and 0 and with a radius 2. So for the third one, we're going to use the same technique, right? So the center is at the point 9 and 0 and the radius is 3. Okay, so if I put everything to here, it's going to be x minus 9 in the square plus y squared is equal to the 9. By simplifying the terms, I'm going to obtain the equation of this semicircle. So the equation of the lower part of the circle is going to be y is equal to the minus r squared minus x squared. So at the same time, we can find the equation of the right-hand side part of the circle and the left-hand side of the part of the circle, where the functions is going to be written as the x is equal to the y, f of y, right? So the equation of the right-hand side part is going to be x is equal to r squared minus y squared, and the left-hand side is going to be minus r squared minus y squared. So now let's talk a bit about the ellipse. So ellipse is kind of the circle, but this radius, the horizontal radius, might be different from the vertical radius. So we're going to call this A as the major axis and B as the minor axis if the A is bigger than B. So the general equation of the ellipse is equal to x squared over a squared. You see, so this part plus y squared divided to the b squared is equal to the 1. So for example, the equation of the ellipse can be written as x squared divided to the 9 plus y squared divided to the 16 is equal to the 1. So let's illustrate this. So I can write here x squared divided to the 16 plus y squared divided to the 9 is equal to the 1. So this is going to show me an ellipse, right? So you see, so the distance from the origin until this point is 4. So this is the a here, right? X squared divided to the 4 in the square. And the distance from the origin until this point is 3 here. It's going to be b. You see, so the y squared divided to the 3 in the square. So we can find the ellipse, and we can explain the ellipse using the functions by finding the y's, right? So in order to find the y, so let me multiply all the 3 terms to the a squared multiplied to the b squared. So the a squared will be cancelled, and I will have b squared multiplied to the x squared. If I multiply a squared b squared to the second term, I will have a squared y squared. And if I multiply the a squared b squared to the third term, I will get the a squared b squared. So let me find the y squared from here. So the y squared is going to be a squared b squared minus b squared x squared divided to the a squared. If I take the square root, it's going to be plus minus of this expression. So basically, if I would like to explain only just upper part or the lower part of the ellipses, I just need to use this equation. So let's do this for our ellipse. If I would like to express this only the upper part of this ellipse, I need to write equation y is equal to square root of a squared, which is 16, multiplied to the b squared, which is 9, minus b squared, which is 9, multiplied to the x in the square, divided to the a. So all of the square root is divided to the a squared, which is 4. Right? So I can just delete this in order to see this ellipse better. So you see, so that this is going to be an equation of upper half of the same ellipse, right? If I put here the minus, it's going to be equation of the lower part of the same ellipse. And at the same time, these equations are the functions because every vertical line is going to intersect with this curve at most once, right? Okay, so now let's talk about the parabola. So every quadratic function is going to be a parabola. For example, you can write a parabola as y is equal to x squared plus 3, or y is equal to minus x squared plus 3. So depending on the sign of the a, we're going to define whether the parabola is looking upward or looking downward, right? For example, if I draw the parabola as y is equal to x squared plus 3, x squared, sorry, it's going to be a parabola which is looking upward with the vertex at the 0 and 3, right? So at this point, I'm going to call this the vertex of the parabola. If I put here the minus, so in this case, the sign of the a is going to be a negative, then the parabola is looking upward with the same vertex here. So now, so it is better for us to express the parabola in this form, x plus a squared plus b form, so because it is more easy to draw them. So let's say we're given the equation of the parabola in this form. I would like to express this in the form a plus x in the square. So in order to do this, I will bring this equation to the full square form. So if I just add the 3 and subtract the 3, this expression can be written as x squared plus 4x plus 4. And we see from here that this is just as simply x plus t in the square. So I can write this the same equation as x plus t in the square minus 3. So from here I can clearly see that this is the parabola, and the vertex of the parabola is minus 2 and minus 3. So in order to define the vertex of the parabola, I need to find the point here for the x so that this bracket is to be equal to the 0, right? So if the x is equal to the minus 2, this bracket is equal to the 0. So that is why the x coordinate of the vertex is minus 2. So once this bracket is equal to the 0, y is equal to the minus 3, it will be the y coordinate of the vertex. So let's draw this. So I would like to draw the x squared plus 4x plus 1. So you see that this is the parabola with the vertex at this point, minus 2 at the x and minus 3 at the y, and it's looking upward. So if I would like to draw just half of the parabola, or it's a parabola in some quarters, I need to restrict the y's, right, to be positive or negative. So you see, so here, if I just draw the parabola, y is equal to the x squared, it's going to be a parabola, and this parabola takes always the y, positive y's, and sometimes the positive x's and positive negative x's. If I just restrict this parabola to be always have the positive axis, then I just need to get the x to be equal to the square root of y, or square root of y is equal to the x. You see, so no matter what you take here, the x will be always positive, right? So let us draw this. So if I just write here the square root of y as the x, it's going to be it's going to be just a part of the parabola, you see? So now if I want to draw the parabola on the second quarter, I need to put here the minus, right? So in this case, I'm restricting the y to be always positive, and x will be always negative. So if I put here the minus sign here, it's going to be the parabola on the second quarter. So this was the introduction to the curves and the equations of the curve.